Welcome. On this lesson, we're going to be discussing isosceles triangles. So, what is an isosceles triangle? So, given any triangle, there is one property that needs to be present in order for us to label this as an isosceles triangle. And that is that we need to have two congruent sides. Given this illustration, let's make AB to be congruent to BC. So, if this is true, if we identify that there are two congruent sides, then we can label this as an isosceles triangle. Now, as a result of having two congruent sides, we also have two congruent angles. But not just any angles, but interior angles, which in this case, let's label them as angle A and angle C. So by definition, an isosceles triangle is any triangle where two sides are congruent to each other, and the result of that is that we have two congruent interior angles. Why is this true? Why is it that those angles have to be congruent? Let's prove that. So let's take a look at the following proof. And we are going to categorize this as the isosceles triangle theorem. So let's see how we can start this proof. Well, let's start by writing down the givens. All we know is that there are two congruent sides. AB is congruent to AC. So we always start off proofs by just writing down the given. Let's show this on my diagram. So AB is congruent to AC. Now for my next step, we're going to introduce an auxiliary line. So now let's introduce a median line, and let's show this in purple. And let's call this point D. So now, by that, let's introduce a median line, AD. And what we're going to say about this, the reason behind it, we're creating this auxiliary line. And again, auxiliary lines are lines that you can just create. Right now, we are creating a median line. Why are we choosing a median line? Because by definition, a median line cuts a segment into two equivalent parts. So therefore, BD is going to be congruent to DC. And this is by definition, this is the median line, AD. So let's show this in my diagram. So BC is congruent to DC. Notice that here we have two triangles. Here we have this triangle on the left, and here we also have this triangle on the right. And those two triangles, they share a common line, and that is AD. So we can say that AD is congruent to itself. That's a reflexive property. And notice what we have done then. If that is the case, let's show this on my diagram. Notice that now we have two congruent triangles. Triangle ABD is going to be congruent to triangle ADC by side. So let's write that down. So for my fifth step, we're going to say that triangle ABD is congruent to triangle ADC, and the reason behind it is side, congruence theorem. And remember that once we have identified two congruent triangles, then we know that corresponding parts are congruent. And what do you notice? Angle B is opposite of the common line. And in addition, angle C is opposite of the common line. Therefore, angle B and angle C are corresponding angles, and they are within corresponding triangles. So we're done. Now we can say angle B is congruent to angle C, and the reason behind it is by corresponding parts of congruent triangles are congruent. So that's the reason behind it. The reason why those angles which are opposite of congruent sides are congruent It's because we have two congruent triangles and corresponding angles are congruent. So notice the order of this theorem. Here we are saying if we have two congruent sides, then we have two congruent angles. And that's what we define as the isosceles triangle theorem. But now, the converse, it's also true. In a triangle, if two angles are congruent, then opposite sides are congruent. So what are we trying to say here? So given any triangle, if angle B is congruent to angle C, so let's show that within our diagram. Now, the converse of the isosceles theorem says is that opposite sides are going to be congruent, which in this case, that will be line segment AC will be congruent to line segment AB. So both directions give you a true statement. Given any isosceles triangle, if you have two congruent sides, then opposite angles are congruent. And the other way works as well. Within an isosceles triangle, if you have two congruent angles, then you can claim that opposite sides are congruent to each other. And this statement, we label it as the converse of the isosceles theorem. Hello. If you would like to continue to learn about mathematics, you can check out the videos on the left.